All right, in this video, we're going to do some examples from lesson 4.2, which are numbers 10, 12, and 14. So in these questions, they're asking us to find all the possible asymptotes, which are either vertical, horizontal, or oblique asymptotes. We are going to be first looking at the vertical asymptote. In the vertical asymptote, you have to figure out what will make the denominator turn into 0, because remember, in math you cannot divide by 0. So if you want to find the vertical asymptote to the graph, because we are going to be graphing these and you have to be able to find these first. If you want to find the vertical asymptote, then you just have to take the denominator, set it equal to 0, and solve the equation. And when you solve this particular equation, you get x equals -9. X equals -9 is an equation, and this is an equation of the vertical asymptote. Okay, that's a vertical line. X equals -9. If you want to find the horizontal asymptote, there's not quite as much work to do to find the horizontal. Takes longer to spell it than it does to actually do the work for it. This one is about you looking at the degrees. If you notice that the degree of the numerator, which in this case is 0, because there's no x here, is less than the degree of the denominator, which in this case has a degree of 1. If you notice that the degree of the numerator is less than the degree of the denominator, automatically, without any work, the horizontal asymptote is y equals 0. And that answers the question. So we're going to have to graph these when we go to actually having to graph this entire function. We have to know the vertical, the horizontal, the oblique asymptotes. Because you have a horizontal asymptote, you are not going to have an oblique asymptote. The horizontals and obliques do not happen together. So that means that this question is complete. I'm going to move it on to number 12. Again, we have a denominator here. I'm just going to abbreviate this time vertical asymptote. And I'm going to say x minus 4 is in the denominator. And I'm going to set that equal to 0 so I can figure out what's going to turn the denominator into 0. And therefore, that would divide this equation by 0. And that means that when you move the 4 across, the minus 4 across becomes positive 4, and your vertical asymptote is x equals 4. Now, if you're going for the horizontal asymptote, this time it's a little different. This time, and I'm going to abbreviate the word degree just to the letter D. If you're looking for the degree, this one is a degree of 1. The denominator is also a degree of 1. This one right here. If those match, now I'm going to go ahead and get rid of this for a moment. If those match, then it is not the rule we had last time where it said, it's automatically y equals 0, because this is even. This is not less than this one. So what you do is you just take the number in front of your highest exponent of x, which in this case is a 2, and you take the number here, and you divide them. So you say y equals 2 divided by 1, which simplified is just y equals 2. And this is a horizontal line that goes through the y-axis at 2. And that completes number 12. Now, we're going to go to number 14. And number 14, again, we got a vertical asymptote, because we have an x in the denominator. And when I set x minus 1 equal to 0, the vertical asymptote turns out to be x equals 1. This time, when you're looking for the horizontal asymptote, which you know means that you are looking for the degrees. In this case, the degree of the numerator turns out to be 2. That's this guy right here. And the degree of the denominator is 1. Oh, that's different now. Okay, so the first example we had, this number was lower than this number. In the second example, we had these two numbers where they were equal to each other. Now, those are the two cases you'll have horizontal asymptotes. When the degree of the numerator is 1 bigger than the degree of the denominator, you don't even have a horizontal asymptote anymore. So I'm going to reword this, and we're going to spell it out, and we're going to say oblique asymptote, which means it's going to be diagonal. Now, to find an oblique asymptote, you have to do a little work to find that. You're going to do a little synthetic division. To do synthetic division, remember, you have to have that little box. And in the box, you put the answer to the denominator set equal to 0. Well, we did that in the first example, which told us it was the number 1. You put that in the box. These numbers are your coefficients of the numerator written out from the highest exponent term down to the lowest exponent term. And I want you to notice there's no x to the first power in here. So the coefficient of the x squared is a 1. There is no x in between the 4 and the x squared, which means its coefficient is 0. And the last coefficient is 4. We're going to divide this, and we're going to ignore the remainder. So let me go ahead and change colors here. The first one, remember, you bring down the first coefficient, and it's a 1. You multiply these two together. 1 times 1 is 1. You add straight down. 0 and 1 make 1. You multiply 1 times 1, and you get 1. 4 plus 1 is 5. Now, the remainder of these problems you are going to ignore. There's nothing there, okay? But as far as writing out your final answer to it, remember that this started off with an x squared. When you divide it by x to the first, you're down to just an x, okay? So this is going to be 1x, and this is just going to be your constant term of 1. So it turns out that your oblique asymptote is y equals 1x, which is really just x, plus 1. And since it has an x and a y, this is going to be an oblique asymptote that the graph will follow. So oblique asymptotes, yes, you have to do synthetic division. And that's something we did quite a bit of in the past. So that completes number 14.